Okay, we're going to talk about a unique problem on a Stern hot hand. This is an m100 system, or if you live in Bally world, a -17 style MPU board. In fact, we do have a Bally -17 in there that's had some battery corrosion problems be blasted and fixed with a coin style battery. But other than that, the game seems to be in good shape and is working, except for one thing. Here, I'll start a game, kicks the ball out to the shooter lane, and you can see that things work. All the coils work as they should, and I mean every coil works as it should. Everything's working, flippers, out hole, everything, except for this center pop bumper. Listen, it's scoring, but it's not popping, opposed to these guys. This guy does not pop. So, how are we going to fix that? And that's what we're going to talk about. With the game off, I like to check the coil resistance on our suspect coil. And you can see that it is reading about 13 ohms, which is what I would expect from a 26/1200 coil. And if you're unsure what the ohms should be, you can go over to a coil that you know is working, like the left one, and check the resistance on that one just to verify that it's pretty close to the same. So the coil appears to be good, but we need to check for voltage at the coil too to make sure that it's getting power. Look at the coil and make sure that the wires are attached, which they appear to be. Next thing is to check for voltage there. The double wires are daisy chained from other coils, like from this one, and we should get 45 volts at both coil lugs. So there, at coil lug, left coil lug, it shows me 40, and at the right coil lug, it also shows me 40. So that means we're getting power to the coil. So the coil is probably good. If we were only getting coil voltage on one side, on one lead or the other, that would mean the coil was open. But since we have power at both lugs, that means the coil is okay. Now we're up at the back box and looking at the schematics. I know that the transistor on the solenoid driver board, that's this board here, that controls our center pop bumper is Q8, which is this guy right here with my big finger on it, and I even marked a C on the board just to make things easier. So what I've done is I've taken an alligator jumper clip, I've connected it up to the ground lug here, and with the game on and in the track mode, you don't have to have a game started. If I ground the lug on this transistor, it should fire that coil. And sure enough, you can hear it. It does indeed fire that coil. So that means the connection from the driver board down to the coil itself on the playfield is good, but it doesn't tell me that this transistor is good. I could suspect that transistor as being a problem, but I don't actually know it's a problem. To be honest, most transistors, when they fail to short. That is, that when I power the game on, if the transistor was shorted, this guy would be energized, the bar would be, the ring would be down. It's not. It's rare to have a transistor fail open. It does happen. You can go ahead and replace this transistor, but I've got a better idea that we try before we do that. Here's some Stern schematics. It's not exactly for hot hand. It's actually for another Stern game, but we can talk about it since the schematic itself is the same. There's two types of solenoids, controlled solenoids on these Bally and Stern games, and that's what's known as continuous solenoids and momentary solenoids. Continuous solenoids, which there's only a handful, would be something like a gate that stays open or the flipper relay that stays engaged, things like that. Momentary solenoids are ones that fire just for a very short period of time, like the pop bumpers and the slingshots and other assorted things. Now, looking at this, and since I know that our controlling transistor is Q8, I can look at this schematic and see that Q8, this right here, is the tip 102, Q8, and it goes back to U3, which you can see shows another transistor, but it's really not a transistor. I mean, it is a transistor, but it's packaged in a CA3081 chip package, which is like a 16-pin chip. It looks like a chip, but it's actually a transistor. Then it goes back to another chip, which is a decoder, a 74LS154, and then out to J4 on the solenoid driver board, which brings data in from the CPU board. So you can see right here, momentary solenoid data, J4 pins 3, 4, 5, and 6. So what happens is that these 4 bits come from the CPU board and are decoded by this chip, and then from that it tells which of the 16 coils can be fired. So by using 4 data lines with bits of 0 and 1 for each one of the 4 data lines, it can tell this chip which one of these coils to fire. So the question is how do we know that all this stuff is working? And that's what we're going to try and figure out. So what the CPU board does is it says, okay, I want to fire that center pop bumper. So it sends out an encoded byte of data, 4 bits long in zeros and ones, over to the solenoid driver board, which is decoded by the 74LS154, and then that tells the U3 chip here to fire the Darlington Q8, which actually fires the coil. So what we can do is, we can't do much about the decoding because that's a thing, we can't even look at it with a logic probe because it's not going to make any sense to us. But what we can do is we can ground U3 pin 16, and if that fires the coil, that means that U3 is working and Q8 is working and the coil is working. So that's what we're going to try first, and that'll demonstrate all these devices if they're working. The only thing that we won't tell us is if the 74LS154 is working, if it's decoding the data correctly. Here we are back up in the head. Again, J4, this is where the decoded data comes in. The top 4 pins of this J4 connector are encoded data that is then decoded by this chip, the 74LS154, which then goes over to this guy at U3 that fires this transistor here. So what we can do is ground the input side of our little CA chip, and you can hear that the coil is firing. That's telling me that this chip is good, and it's telling me that this transistor is good, that both of those things are good. Now it isn't telling me that the signal is being decoded correctly, but it is telling me that this stuff downstream is working. The MPU board sends out some encoded data through these 4 wires up here, each wire representing 1 bit. It comes over to the solenoid driver board through these top 4 wires. Again, each wire is 1 bit. The 74LS154 decodes that and then tells one of these 3 pre-driver transistor chips to drive one of the tip 102 style transistors down here to do the associated coil, do the correct coil. Now if one of these bits is missing, this guy is going to decode the information, meaning it'll either fire the wrong coil or it won't fire any coil. So say that our pop bumper over here, the MPU wants to fire our pop bumper. Okay, so you get a switch input that the pop bumper has, the ball has hit it. The MPU interprets that, says, I don't know what the encoding might be, maybe it's 00, or maybe it's, figure it's 1101, I'm just making that up. Sends it off this, through that connector, through this connector, this guy decodes it, and then ultimately ends up firing Q8, which then fires the pop bumper. That's how this works, because it's a momentary solenoid. It has this decoding thing that's all done. That way there's only 4 lines used to run all 16 coils. But say that one of those bits is missing, then it's misdecoded, and it doesn't know which coil to fire, or it fires the wrong one, or doesn't fire anything at all, and then we have nothing. So we know that the pre-driver transistor in this little chip package and the Q8 itself works by grounding the input pin. We could see that that whole series works. Now notice that we haven't replaced anything yet, but we have figured out what is working. We can't really test this chip, but I still, you know, these don't go bad often. So I'm still kind of approaching this that we're missing one of the bits, that one of the bits in the whole process is missing. And I think what I want to do is go over to the MPU board and just make sure that that there aren't any broken lines. We're back to the schematic, but this time instead of the solenoid driver board, we're at the MPU board. Notice right here, it says momentary solenoid data. This is on J4, pins 1, 2, 3, and 4. Those top 4 pins on J4, which is this connector over here, the top 4 pins, 1, 2, 3, 4. So what I want to do is see where this information goes. So what it does is these 4 bits goes through a resistor, each one R97 to R110, and then you get PB0, PB1, PB2, PB3, which then comes over to the PIA, and that is U11 pin 10, 11, 12, and 13. So I want to make sure that there is no broken line from this guy, the PIA, all the way to the connector J4 pins 1 through 4. The reason why I'm suspect of that is because this is U11. This board had some battery corrosion before. It could easily have a line broken between this guy and the connector here. So that's what I want to check now. Okay, so I got my multimeter out, set the buzz tone, and I want to check to make sure that each one of these pins goes off to the resistors like it shows on the schematic and ultimately ends up on the PIA. So I'm at the first topmost pin, and I can see, and then the second pin, that I'm getting to each one of the resistors, and then the 4th pin, so I'm getting to each one of the resistors. Now the next thing is to check the resistance of the resistors. I think they're like 470 ohms. And yep, they're all checking out okay. So the resistors aren't open. So we look good so far. But now I want to check from the resistors to the PIA. So I'll start here. Got that one. And then I have this one. And I have this one. And then I have, no, I don't have this one. So look, the board is open. There's some problem here where I'm not getting a buzz tone from that resistor over to here. So that's why I am missing a bit, and that's why that pop bumper is not firing. Now with that trace fixed on the MPU board, pop bumper now works. So the conclusion, it's not always a problem with the solenoid driver board when a coil doesn't work. It can go all the way back to the MPU board, and a problem there can manifest itself back. And you've got to trace it from the beginning, the MPU board, through the solenoid driver board, down to the coil itself. And I hope this process has helped explain that.